All right, so this paper 2 question came from October, November 2013, paper 23, question number 3, define velocity. You should have written down the rate of change of displacement. Define acceleration, the rate of change of velocity. Very straightforward. If you've got those definitions in mind, 2 marks there. If you put anything else besides that, correct it. That's the way you want to think about defining velocity and acceleration. Velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. Now it tells us a car of mass 1,500 kilograms travels along a straight horizontal road. So it's one-dimensional motion, right? Just looking at the horizontal dimension. The variation with time t of the displacement x of the car is shown in figure 3.1. And that's it. There's no question. There's like, oh, that's a nice little setup there. Awesome. All these ones on the back. Yeah. Use the figure to describe qualitatively the velocity of the car during the first 6 seconds of the motion shown. Well, only the first 6 seconds. Why? Oh, that's all the motion. So it's like, that's all of it. So the velocity starts out non-zero, and then it kind of slows down right here. So you have to draw and interpret displacement time graphs. That's the learning objective. Here we have a slope, right? The slope of displacement time gives velocity. So here it starts out at some non-zero speed, and then as the slope shallows out, that means it's going slower. So it's like it's going at some speed, and then at about 3 seconds or so, it hits the brakes. What is this? Yeah, car. So it hits the brakes, slow down a little bit. See how here it's covering less distance, right, in the same amount of time. Like here's 3 seconds, it covered that much distance. Here's 3 seconds, only covered this much distance, right? So that curve indicates slowing down or acceleration, right? That's a type of acceleration. Deceleration, slowing down. So something in your own words to that effect. Give reasons for your answers. You should sort of talk about the gradient because the slope is steeper initially, it has faster velocity, and then it slows down. So you have to realize that the slope of that line gives velocity, and your reasons should sort of go back to that. Okay. Any questions on these 3 marks? Leave it down in the comments below. Calculate the average velocity during the time interval 0 to 1.5. So there, and hopefully by the time you made it to that, if the other part of it was a bit unclear, you said, oh, I know how to do this. I'm taking the slope there, right? Your favorite. So at 1.5 seconds, it looks like it neatly intersects. It doesn't really neatly intersect it anywhere, does it? But at 1 second, it's going right at, what's in between 20 and 40? 30. Nobody took out their calculator for that. Good. All right, so we rise 30, we run 1. Now get the calculator out. 30 over 1. Just kidding. So meters per second, right? So we have a velocity of 30 meters per second, right? It rises 30, it runs 1. You could have maybe used your judgment and said, well, it's like about 45. Okay, right in between here. So this is 50, and each one's what? 42, 44, 46, 48, 50, 52, 54, 56, 58, 60. So it's kind of in between 44 and 46. And wouldn't you know, 45 over 1.5 gives you the same thing, right? Yeah, 30 meters per second. So the average velocity, 30 meters per second, with either a calculation of rise over run. So we're rising 30 meters in 1 second, right? That's the displacement. Oh, they're calling it x for displacement in this problem. X over t, that gives you v, distance over time. Show that the average acceleration between 1.5 and 4 is negative 7.2 meters per second squared. Acceleration is the change in velocity over the change in time. So the initial velocity, we already calculated it. I just called it v here, but it's u, right? It was initially going at 30. What is it going at around 4 seconds? Well, if you can calculate the slope down here, you can calculate the slope up here, right? And so it requires yet another calculation of slope. And so if you hone in on the point 5, 110, that looks like a really nice point that intersects the graph nicely. And then how about right here at 4.5, and that looks like it's 104. 4.5, 104. There's probably lots of good points somewhere along, but once it sort of levels out, now it's going at a constant slope again, you find 2 points and you can calculate the slope with. So my calculation would be 110 minus 104, the difference in my y coordinates there, over 5 minus 4.5. And I can show that the final velocity, right, it's slower, so deceleration makes sense there. 110 minus 104 is 6 over 5 minus 4.5 is a half. 6 divided by a half is the same thing as 6 times 2, so that's 12. So it goes 12 minus 30 in, and they gave us the delta t, right? So think about this as like, in general, acceleration, delta v over delta t. Well, the change in velocity means we've got to like calculate the slope twice. Thankfully, I already did one up here, right? That was the initial velocity. The change in time is just from 4 to 1.5, right? Like at 4 seconds, it was going that fast. At 1.5 seconds, it was going that fast, right? Because they told us right here, from 0 to 1.5, all right? So this is our acceleration calculation. The change in velocity over the change in time. You got something like that, probably got these 2 marks. So then that should work out to negative 7.2, right? So 12 minus 30 is negative 18, and 4 minus 1.5 is 2.5, right? 4 minus 1.5. I like using a calculator, even when mental math is kind of not too bad. Get a calculator, might as well use it. 18 over 2.5 is sure enough 7.2. That's always nice. Now, this is chapter 3. I know I just gave you like the answers for chapter 3 from your textbook, so maybe you haven't got to that yet. Calculate the average force. Force equals mass times acceleration. We know the acceleration because we just calculated it, and they gave us the mass way back when, 1,500 kilograms. I'm like, oh, they told us that for a reason. And even when you start reading it here, you might anticipate, oh, we're going to do like a force calculation. That's m, and I could use F equals mx. So if you just multiply those two, that's the average force. You can report it as negative. In other words, it's a force that opposes its motion, right? It's moving down this horizontal road, but it slows down. So the acceleration vector has to oppose it in order to slow it down. I don't think they would mark off with a negative sign. So if you had it or if you didn't have it, give yourself the points, be 10,800 newtons, or 1.08 by 10 to the 4, you know, if you like your scientific notation there. Yes, YouTube, that is the bell to dismiss students here on campus. Have a good weekend, everybody. We'll see you next time.